Before we start, can I ask all of you, do you use MATLAB?
Yes.
Can you open your MATLAB? Anything you are comfortable. I will show in MATLAB, but you can use in anything, Python or whatever you are comfortable with. Okay. So, good afternoon everybody. Today we will see the lecture 6, or you can say the tutorial 1. And the main content of this is basically whatever we have covered till the morning. So here we will try to look into some of the numerical problems, not some, maybe one or two, because we have only an hour. We'll also try to look into one or two MATLAB codes, that how we could actually possibly use some of this handling missing data. And then I think I will also give you some of the home assignments, and unless it is more not like further study, but rather than that, my suggestion is to kind of try all of this. And as I said, that if you can finish some of that and send it back to me, so you can use words, LaTeX, whatever you are comfortable to write down your answers. And then as I said, that if you kind of also write down the scripts and let me know, or send me the email to me or Shamin accordingly. So let's first start with the first one. So we are talking here about the missing data first. So what we want to try is that we want to clean the data or reduce the noise or normalize it, okay? And we will do it using the PCA, what we have just studied today morning. So in this kind of problem, you will see we could do it in several ways. So I will show you one of the way, and I will ask one to do at home. And the objective is, as we understand that you know why the missing data is important, why we kind of try to fix it, we try to normalize it, for fair comparison. We have already seen it today. So we will try to use PCA to compress that, right? That means that you will have missing data, but the expected value that are not recorded, okay? That's what we will try to look into that. So now if you will let's try to first see the problem 1, okay? This is tutorial 1, not the tutorial 2, okay? So tutorial 1, I think I have given you to do the test, do it at home, so we'll talk about it later. So first let's see the first problem, where we are trying to simple imputation method. And if you can see these lines, can I ask all of you to type down on your MATLAB? Let's start with the first one, okay? So we are looking at the very simplest way here. We are looking into the very fastest way to patch the gap. And this has been called as a simple imputation method. So the goal is not to invent new information for us here, but to keep our pipeline running without biasing it too much, okay? So the first what we have done is here, you can see that I have created a tiny example of vector with holes, okay? So now if you will look into here, we have the values 1, 2, then the third one is missing, we have the values for 4, then fourth one is missing. Similarly, after 6 and 7, 8th one is missing, and then we have tried to kind of created a tiny vector like this. Can you try to do the same? Abhishek, can you actually monitor if there is any online questions in between? Yeah, you can do that. Anything, whatever you're comfortable. So basically, you try to write down a very similar example of a vector. Okay? And then you can put the missing data at the 3rd position, at the 5th position, as well as in the 8th position. let me know when all of you are done. So let's go step by step. First you try to create this vector.
We see that here,
Have you all done it? Just create the this simple line of vector and give some kind of holes, which is like we are denoting here as an AN. So if you use something else, you can use actually some other terms as well. Is it done? You have to introduce 3 of these cases, right? And then once you put this vector, then what we do is that we try to call this by using the term as file missing here, okay? That means we are trying to kind of talk about what is being missed here, and that's what we will try to do here. So basically what this means is that only where A has n, that means the missing factor, that will be replacing by its moving mean, okay? That will be computed over a window of 5 samples. That means 2 on the neighbor to the left, 2 on the neighbor to the right, and the center on the gap. And then MATLAB will try to ignore this term NaN when it computes that mean. So can you try to write down the second line as well? So we are using the term move mean, that means we are using the moving mean computed over a time, and we have given the 5, that means a window of 5 sample we are going to take as a consideration, okay? So what will happen in this case? In this case, what will happen if you look into the third position here? That means that in this 3, the 5-point window will be 1, 2, then NN, 4 and NN, right? So now if you will try to kind of calculate the mean here, so MATLAB will automatically ignore this term NN. So that means 1 plus 2 plus 4 divided by the 3. Then you are going to get something like 2.333. And that's going to be your third term. Similar way you will also do for the window 5, we will do for the window 7. So now can you try to calculate this, okay? At least go till the second line and let me know once you are done. Once you will do that, you will get an output like this. So everything else will look very similar. Only the extra terms will be added where the terms are missing. Okay. And please remember here we are doing imputation, we are not doing smoothing. So this process is being called as an imputation. The original non-missing values are actually untouched. Okay, so we are not touching any values which are there. And also remember that this can only work out if the window values are important. So window value, for a larger window value we have to use more context, but can blur the local behavior also. So a smaller window value reacts very easily, very locally, but it can be unstable. So for time series with irregular spacing, we have to use the sample points option, so the window is in the second rather than the sample count. Now can you try to let me know whether you got the last line? Anyone else? We try to got something like this. We have 5 more minutes and then we will move to the next problem. Okay, so can you try to let me know if you have done it? we will now move into the next problem. Before we move to the next problem, I'm asking last time any issues you are facing? Yes.
So, is there any arbitrary when will you choose the window length of file? How do you choose that method?
Because we have a very small numbers here, that's the reason we have tried to take as much length as possible. You can take more than that as well, then you will have like more efficient one, but I have taken 4 of this because then there will be another NaN as well. So just trying to avoid that, we have tried to give 2 from here and 2 from this side. Because if we will try to calculate 5 from this side, we cannot go on the left hand side. That's the reason we have taken 2 from this, 2 from this side, because we don't have more numbers on the left hand side. Yeah, if you have like 3 on the left hand side, 3 on the right hand side, you can take it, but we don't have that option, that's why. Done? Have you done it? Okay, then I think again I will say that go and practice this one. I think you have understand that the whole process is a very simple imputation method. To try with different values and try with different places of this NaN position, and you will be possibly getting similar ways. Okay. So now for you to practice, I want to give you one of the another practice simple imputation using exactly what we have done in the previous one. So you recreate the matrix which is shown here using the NaN. This one, right, and fill in 2 ways. First is that you try to fill missing the linear and try to fill missing the movement. There are 2 ways you could do that, and with at least 3 window sizes. That means 2, 3, 5. Okay, and then explain the number you get at each point. Similar way, the missing entity. Why does the linear give those value, and how does the moving average change with the window changes? Okay. So you use it for 2 ways. One is the fill missing, which you can see I have written here, and one is a similar way you use it as a movement. So linear and the movement, they are the 2 ones. Try with the same 2. Try to visualize your result with a small plot or printed matrices and discuss the age issues like where it start or end, the NaN starting, consecutive NaN, the gaps you try to understand. And when you submit, I will suggest to submit a live script. That is, you can submit either point .mlx file or whatever file you are using with a 1-page reflection. Okay, you can take a screenshot or the photo of this, and so that I can move to the next problem. Two ways you have to do. One is the fill missing linear and one is the movement. Okay. We are done taking the details of it. I think I will go to the next problem. Okay. So imagine we have collected the vibration data. If you have any problem, you can discuss. Otherwise, let's try to move into the next problem. Okay. Right. So we have collected the vibration data from 2 different bridge spans using the accelerometer. Okay. Span A gives us how the vibration reading, and span B gives us the higher reading. Okay. So span A will be giving you low one, and span B is giving you the higher reading. But, and here's the key, that we don't have the label saying which is healthy, and we don't have the label to say which is damaged. And this is a perfect case of unsupervised learning where we let the data tell us about the pattern. Okay. So if you look into that, for the data we have span A amplitude, vibration amplitude, which is 0.2, 0.3 to this one. Similar way we have span B amplitude, which is 0.15, 0.18, 0.16 and 2.0. Okay. So the first thing is that what we need to do. Can we try to concentrate on the current problem? Can we try to concentrate on the, excuse me, can you try to, let's try on that. We'll talk about what you have problem, right? Yeah, so what is the next step we need to do here? We calculate the mean amplitude. right, for the span A and span B. So now if you try to calculate the mean amplitude, can you tell me what will be the mean amplitude for span A and span B? And can I ask all of you to please bring your laptop for the next tutorial, otherwise it will be problem to kind of do it further, okay? So can you let me know what is the mean amplitude for span A and span B? It's basically this one, this one, this one, this one plus summation of this divided by 4. So what is the span A mean amplitude? So if you will try to calculate the mean amplitude here, you will be getting for the cluster 1, or you can say span A, you are getting the low vibration, and then the value is going to be 0.02875, and for the span B it is going to be 0.1725 square. Can you confirm if you got these two values, right? So what is the next step we do? We kind of assign each data point to the nearest centroid. We calculate the distance from each of the reading to both the centroids. So for all span A reading are closer to the low vibration centroid, and if you see the span B, they are reading are closer to the high vibration centroid, right? That means your centroid 1 is this one and your centroid 2 will be this one. So now what is the next step we need to do? Let's go back to the question again. So what is the next step we need to do? We have calculated the mean amplitude for each span, right? So using a simple 2 cluster, that means k equal to 2 approach, we have to assign each measurement to the cluster 1 or cluster 2 based on the distance to the mean. So that's what we do for span A and span B. Here cluster 1 means the span A, cluster 2 means the span B. Basically you compute the centroid after the whole thing, and then you stay essential for the same. So cluster 1 is, if you go back here, it's going to come, or the span is this one and span 2 is this one. So now we need to understand, or if you go back to the question again. So what is the next question? The discuss what clustering results might indicate about the structural condition of each span. So now what you need to do? You have to do the interpretation, right? And how we do that? How we understand which one can be healthy, which one is not healthy. So let's look into the span A or the cluster 1, which is having low frequency, low vibration, right? So all span A readings, if you will see, they consistent with the stiffness. That means they are healthier response under any comparable condition, isn't it? Similar way, if you look into the span B, they are having high vibration. That means all span B readings is going to or could indicate reduced stiffness or some way like loosened connection or different kind of boundary conditions, right? So now if you try to interpret that, and this is the general, this is just a figure to kind of let you understand how between these points it could look like, how the centroid could look like. So this is just a simple way for you to understand, imagining the whole situation. So if you look into the cluster 1, as I said, it is having low vibration. That means it represents the beach span with low vibration amplitude, likely healthier or stiffer response. That means if you look into the cluster 2, that represents the span with the higher vibration amplitude. That means it can indicate more flexible or deteriorate structure or simply different loading condition or reduced stiffness cases, right? And this is important takeaway here, because even as I said that when you started looking into span A and span B, we didn't know which one was the healthier. or which one could have some the damage or any other issue. So this is important takeaway here, because even with a very simple calculation you can see, you can demonstrate the essence of k-means clustering, and we had no labels, yet we can identify two distinct groups here in the data, right? And this is exactly how unsupervised learning we do to help us to understand how structural health monitoring works. It actually highlights the patterns or somewhere the anomalies you might not have recognized otherwise. Okay? And this is a very good example of the unsupervised learning. Now let's try to look into the another problem. We have a steel beam with cross-section area 0.02 meter square, and the modulus of elasticity is 210 GPa. Okay, so and the tensile load is 150 kilonewtons. So now how will you compute the, and this is very much similar to how the strain gauge actually measure it. Okay, and what we are interested to measure, the resistance. So now how can you calculate the stress? This is a very simple engineering semester 1 problem, but still it's very important to kind of revise it. So how will you compute the stress? Yes. So basically your cross sectional area is A, your modulus of elasticity is E, tensile load is P, right? And a strain gauge with a factor is 2.1. That means the stress is going to be load by area, as you said that. So if you calculate the sigma, what is the value of sigma? Sigma is nothing but P by A. We put the value of P here, which is 150 kilonewton, and area as 0.02 meter square. So what will you get the value of sigma? Sorry? Sigma is very simple. It's the load by area. You know your load P, you know your area as 0.02. You can calculate sigma.
So previously the same thing can also be done in MATLAB?
Absolutely, yeah. So I have just, some of the cases going to be mixing of that. Some I have given you MATLAB, some I have you hands-on. You can definitely write down and everything has to be done in the MATLAB or coding and all of this. Can't just do it hands-on. Right? It's a process we are understanding. Tell me the value of sigma. Yes. Right. So now, if you go back to the question here, then what is the value of strain? Strain, we know what is the value of strain. Stress by modulus of elasticity. That means epsilon equals to sigma by E. So you know the value of E, you know the value of sigma. Can you tell me the value of epsilon? Right. So now let's go back to the question again. If a strain gauge with a gauge factor of 2.1 is attached, we have to calculate the change in resistance if the initial resistance is 120. So what we will do now? You got your stress, you got your strain. Now you have to do the interpretation, right? So your gauge factor, what is the equation of gauge factor? Gauge factor GF is equals to it is related to the fractional change in the resistance as well as the strain. That means delta R by R divided by epsilon. Do you remember this? So now the delta R, if you try to calculate that, everything is known here, so the delta R will be this one. So the resistance increases by 0.009. Similar way you can actually do that by using a MATLAB code. So now can I ask you to write down this as a MATLAB code, not now, once you go back, because we don't have time for that. But can I ask you to this is a very simple way to do that. Can you go back and try to write this as a MATLAB code, and or even if you use Python, whatever works better for you. So basically what you do is that, if you look back into that, we have a steel cross-sectional beam. The cross-section has been given. So you write down all these details somewhere here. So the steel beams, you write down all the information in the beginning. Then you write down the equation of stress. You calculate the stress. Then you calculate the equation of strength. And then you write down that if the strain gauge with the gauge factor 2.1 is being attached, then how will you calculate the change in the resistance? By using the same equation. Okay, and try to look into that whether you are getting the value of delta R in a similar way. Is it clear to everybody? So now this is also another home assignment. So we are looking at the reinforcement learning agent that schedules the inspection of a dam. Okay. So the problem gives us 3 key reward components. Each of the inspection costs 10 reward points. Okay, and that can be a penalty as well. Detecting the damage early earns 30 reward points. Failing to detect the damage can cost 50 reward points. Okay. So in one of these, the agent performs 2 inspections and detects 1 damage case. So our task is to compute the total reward and then think about how changing inspection cost affects this policy. So you have to calculate the or compute the total reward, and then you suggest how the changing inspection can cost to 5 points affect the agency's policy. And this is I think a very good diagram to kind of show you the whole process, how the dam actually started the scheduled inspection, how they got the reward, and if you don't get it, then it's going to be -10. Okay. Now can I ask you to take a photo of this and solve it once you go back? Can you check if there are any questions on the online? Can you write down on the chat if they are okay or if they have any doubts? Is it clear to everybody the problem? So when can I expect to get the answer? By tomorrow? Okay, perfect. So now let's try to look into the another important factor, which is noise reduction. Especially the concept of smoothing here we are talking about. Previous one you have seen the imputation. So smoothing is, as we know, is a data analysis technique we use to reduce the noise. And there are several more complex scenarios also. There are Fourier transformation smoothing. There are even Kalman filtering smoothing, which is great systems. Okay. So if you look into the MATLAB plot, you will see here this one, right? You will see that there are 2 curves, and the jugged one is the input data, okay, with full of noise. And the smoother one curve, you will look it very closely. I don't know if you can see it here. So then the smoother one is the average filtering data. So now let's try to do it using the MATLAB or whatever software you are using. So let's try to kind of look into the practical example, especially moving average filter. We are trying to use that. So we have already learned that the smoothing helps revealing underlying trends by reducing the noise, right? So now we will exactly see that. So in the first phase, what we will do is that we will block at the top. We first create a noisy sine wave. So now can you try to do that? Have you done that? All of you? Okay. So once you are done that, then can you generate 100 time points between the -5 to +5? Similar way, I think I have shown you here. And then add random noise to the sine wave. This will simulate the kind of noisy data we often get from the real life sensor. Let me know once you are done. So once you will add the random noise, what do you need to do? You have to apply the moving average filter, right? And then we define this, meaning each point will be average with its two neighbors on each side, okay? And then we will be creating the average coefficient. That means y equals to filter b comma 1 x. So basically you are applying the filter to the noisy data. This is the key part, that instead of looking at each point individually, we are replacing with the average of 5 points, which smoothens our fluctuations, okay? So let me know once you are done applying the moving average filter. So now once you are done, the next part is the interpretation of the result, right? And that means plotting the results. So we will plot the data. So the final section of the code will plot the original as well as the filtered data. That means you will be getting two of this graph, right? One is on the red, one is on the blue. The input data is being said as red and the filtered data is said as the input data is being mentioned here as a blue and the filter data is being mentioned here as a red, okay? So we need to kind of plot two of this. So first we have said the plot the first one and then plot the noisy data. And for plotting the smooth data also we write down this plot t comma s line with this. So basically this is the two ways that we plot it. We plot the first one and then we plot this without the noise or the smoothened data. Okay? Now can you let me know whether you got these two curves? Got it? How about others? Okay. Anybody else? On the same plot. Just like this. Did you actually try to include the sign one? So check this one whether you have tried to include the sign there.
Yes, ma'am.
Then you should be able to get exactly the similar one. Show me how you are getting. No, just flipping around. You don't need to come. No, I think there is a problem with the sign convention. Yeah. Yeah, it's. I think you have given a random one. Yours is perfect. Yeah. So remember that when you are generating 100 points, you have to do between -5 to +5. Have you done that? Have you created a sine wave? Check that. I think you have selected random points instead of the sine curve. So check anywhere if you have given the sine wave. Even for the random noise also we are trying to give the sine wave, right? So that's the reason both of these are looking similar as a sine wave. So check that. And also try to check with during the moving average filter whether you have done it correctly. But your plots are showing the random filters. Anyone else got the same curve? All of you? So So now one of the very important question is that why it matters. So now can you tell me that why smoothing matters and why the imputation is important and how is different than each other? You have done this now, you say.
Because otherwise, if we don't remove the noise in part, then it will overfit. Like those high frequency points will also be incorporated into the model, and that will overfit the model.
When we do smoothing and when we do imputation?
If we don't have some data points that
Missing, yeah, something is missing.
then we do the imputation.
Yeah.
And we do the smoothing if
There's a noise.
if we intend to get some smoother plot, but there is some noise due to that we
Yeah.
more spikes.
Perfect, yeah, correct. So who else didn't get this graph? Should we move to the next one? Have you tried it to get the similar one or they're still you're getting the same? Maybe we can look into the program once we are done with the lecture, okay? Perfect.
Where is the noise?
I think you noise, there is no noise, you got the same two cars. Did you introduce the noise?
Which one? This one?
We must have not introduced the sine wave noise, did you?
What is this? No, no, this star one. This one will cross one. Cross one, this cross, otherwise this cross. Same. But it is showing some Oh, why there is a semicolon?
You also check your code again. Maybe there is some kind of star or anything which is missing. One minute, yeah. So first you have to introduce one sine wave with noise, right? And then you have to apply the average filter to get without the noise. Yes, sorry. Best curve fit is different than when you have the points, then you are trying to get the best one which is matching with the data points, right? And smoothing is like that you are removing the noise or some kind of outliers which is there to get the, so if you have, maybe your data is actually look like this, right? But due to the noise or some kind of outlier, it some may look like this. So to know exactly how does it, how your exact points are, we try to use smoothing.
Mathematically it has to compute something.
Yeah.
We are trying to smooth the curve. Mathematically it has to.
Yeah, there are kind of certain filtering method, right, which we use. Here, like we have used the average filtering method. You know, there are some, like there are KL filtering. There are a lot of filtering methods, and there are a lot of ways that you can actually remove the noise, depending on what kind of also noise do you have. That also have a separate other study that what kind of noise. We do quite a lot in uncertainty quantification or when we're taking the big data. But smoothing is basically your data basically maybe look like this, but due to some certain outliers or noise, it does not show you the exact weight. So then you remove this and try to get, maybe you will not get the perfect one, but maybe something similar to it. If everyone is done, then maybe we can quickly move to the another one. So this is also now, let's look into the another powerful technique which is noise reduction, and that is called as a low pass filter. Okay. So the low pass filter, actually you can see that. So what we have seen before, I think we have seen that averages for general smoothing. So now why we do low pass filter? I think a low pass filter allows the slow changing or the low frequency component, right? And how we do that? So if you will try to kind of, and this is a very short one, we are not getting into much details into that. I will say that go and practice this. So now if you will try to look into that, first we try to generate the ECG signal. Here we are trying to give you an example of ECG signal. So the MATLAB code first create one period of ECG signal and we write it as x equals to ECG 500. Then this ECG like signal of 500 data points. So we have given 500 because we want to create 500 data points. You can give 1000, 5000, whatever you want. And think of it as a raw hard signal before any cleaning, right? And then we will be applying the SG filter. SG filter has been also called as the Savitz-Golay filter. We will call it the SG filter, and then we write down some this like, and this is being written as like SGOLY filter, and that's how we try to define this. So when you write on the math work, you go to the help. This will, if you write down the name of the particular filter you want to use, they will exactly tell you that what is the short form of the filter. Okay. So once you apply this SG filter, then you can see that what is the next step after we do. That means we are asking it to kind of filter using the SG polynomial smoothing filter. So what is the next step we do? We check the result. And how will you check the results? We write down the size of the Y. So what exactly M and N means here? So basically what SG filter does, it actually kind of, or some way, a very sophisticated form of low pass filtering method, right? Instead of just averaging the points, it fits a very small polynomial to the data within a moving window, okay? And this is particularly valuable for ECGs and some of the critical diagnostic cases. Okay, so this is one of the examples. This is not quite this one. So now, with the low pass filter, what I will ask you by using, so you may take a screenshot of this if you want to, before moving to the next slide. Okay, so by using this particular approach, I will say go back and try to solve the similar one, but this is more little bit complicated, okay. So I will like to take what we have just learned, which is low pass filtering, and practice it by yourself in the MATLAB. So here you can see that a code template I have already given you for a time scope, okay. This time scope will allow you to display both the noisy signal as well as filtered signal simultaneously, right? So your task will be to initiate and configure the time scope as is been shown here, and then run your own low pass filtering experiment. You can use the same method as well. So try changing the time span. For example, you can say that take 1.5 seconds to 2.5 seconds. So it can vary from person to person depending on how you want to do. And then note how the display changes. Then you try to adjust the Y limit if needed to see a larger result. Okay. And then once you are confident enough, then try modifying the low filter parameter, and then you see how it is affecting your filter. And then once you are done, you can take a screenshot, you can write the code, and then you can see that how the noisy and the filtered signals look like. Okay. You can take a screenshot of this and then try to plot your own data for time scope. Is it clear to everybody the assignment? So now if it's clear, I will go to the next one. This is also a very theoretical one. I think if you remember that we have talked about this triple bottom line, and which proposes that your economy, your society and the environment, they all should kind of be in the same line. You remember on the very first lecture we have talked about this, and that's how your sustainability infrastructure work, okay. So now what I will let you think about it, and if by using this triple bottom line method, can you propose two measurable indicators for each of these cases, for environment, for society, for economy? For each of these cases, two of the parameters, you can think about it, okay, and try to think how it could possibly affect by using the triple bottom line. Clear to everybody? Right. So now let's go to the last assignment. This is also very very similar to what we have seen on the first one. You measure the degraded strain, that means micro strain, and ambient temperature at 12 equally spaced free. So one strain value is missing, which is somewhere here. Okay. So you can see all these strain values and then all these temperature values, and one of these data is missing. So the first is that you impute the missing strain at t equals to 5 by using any robust method and justify your choice, like why did you choose that particular method. Okay. Second one is that you compute the 3-point tailoring movement average of a strain t equal to 3 to 12 after the imputation. So, and that means we are talking about imputation because we have a missing data, and show the first two windows calculation explicitly. Okay. So basically you will first take the imputation where t equals to 5, you calculate the imputed value which is missing here at this point, right? And then you will use the 3-point trailing moving average of strain where t is going to be 3 to 12, and then you will be calculating all the values of t. Clear everybody? And once you are done with that, then you will identify one point anomaly and one contextual anomaly, that means context equal to temperature, and explain each in one line. That means you will write down one point anomaly, that means you can write maybe t equals to 8 some way, and then you will be writing one contextual anomaly, and then you calculate the value, what is the value you are getting, that means what is the value will be at t and equals to 8 and t equals to 11. Clear? If you want, you can take a screenshot of this. Any doubts till now, any one of you? If not, then I think we will end the tutorial here, and I would expect all of you to kind of start working on the assignments and let me know if you have any doubts until I am here. And as I said that please try to send me the scripts, and then if you have any issues to write down the scripts also, then get back to me. Okay. So yeah, thanks everybody. I think I will see you then tomorrow. So I think the online audience, do you have any questions from the online audience? Any of this kind of the terms I have used, those are all available in the Mathworks. Yeah, just okay. I think I don't have the reference. I can show you tomorrow. That I can show you the list of this, where you just click on this, you will get all the details there. Just type the exact name, you will get the.
Some assignments in
Yeah.
Jupyter Notes, so I
Yeah.
cannot use that ECG. I have to use MATLAB.
Yeah. So all of this, whatever I have shown, you can use MATLAB. But please remember that all of this you can also use in Jupyter or Python. But only the terms we use going to be different. So if you go and go to the help, if you write the exact term, you will if you're using tail expansion, just write down the term. They will exactly tell you the shorter form you need to use it. Okay, thank you everybody. I think from the online audience also we don't have any further questions. So we will end the lecture here, and I will see you all tomorrow. এটা আটকে গেছে বলতে আমাকে নিয়ে তো বলবে না এটা
those sign translated
Ah.
into the rand, like
Ah.
random for
Random here.
calls.
She has added
No,
random
no, no.
next line. Okay. Y equals to x plus 2 multiplied by what was the range? 50 to 120? Minus pi to pi. No? So then, apart from this 120 is 50 to 120. Where is the pi? You have pi is minus.
Next time you bring a laptop, otherwise you won't be able to catch up. But you understood the other section, go back and read the